Okay, welcome back. What I want to do now is to continue with Unit 3 or 4, and this is the last session. This is session 14. External influences for the selection of wiring systems. So let's just make sure we got all of this in place, okay? Again, level 3, okay? Okay, right, let's move on. And again, remember to extract the information, make it your own, write it out. Don't just assume you can recognize it from the screen. Okay. Right, here are our learning outcomes for this session. Okay. And just make sure I can clean this off first. Okay, so, sorry about that. Okay. Okay, wiring systems. Okay, now just bring this into view for you so you can make sure it's readable firstly. Okay. Just pan back, make sure everything is in view. Okay. Let's check there's nothing missing. Okay, good, very good. Now BS 7671 defines a wiring system as an assembly made up of cable or bus bars and parts which secure and, if necessary, enclose the cable or bus bars. Now a wiring system therefore is not simply a run of cables. It includes the cable or bus bar, the means of supporting the cable or bus bar. For a typical PVC installation in a dwelling, this would, for example, be the cables and the clips and mini trunking and capping or conduit that the cable is supported by or run in. The choice of wiring system is dependent on a variety of factors, including external influences, compatibility, maintainability, and the type of installation system. And here we have external influences. Let me just make sure we can get that in full, right? Okay. Okay, external influences. Okay. Now, Chapter 32 of BS 7671 points the reader to Chapter 51 and Appendix 5. Regulation 512.2.1 requires that equipment is of a design appropriate to the situation in which it is to be used, or its mode of installation takes account of the conditions that are likely to be encountered. Okay. These can include temperature, sunlight, water, animals, etc. The chosen wiring system must match with the environment factors. Now, bear in mind that when you install cables, especially if these cables are clipped to a surface, or for instance running through a house loft or something of the sort like that, be aware that you can have little rodents like these eating away at your cables. Okay. And although you would think that the natural instincts there would that these little rodents would get electrocuted, often they are not. So they end up causing massive damage. So these are some of the environmental factors which you need to take into account. Okay, let me just pan up, make sure we get it in. Okay. Okay. Okay, thank you. So okay, just trying to see if I could get a clearer picture. Or better. Okay. Classification of external influences. Okay. So let's look at that. Okay. Let's go to that. Make sure we can get that in view. Overview. Okay. Classification of external influences. First letter, the general category. Okay, so what I'm going to just show you, bring this into view for you, so you can see it. Okay, go back a bit, go down, and let's make sure we can get it all in. Okay. The coding listed in Appendix 5 of BS 7671 helps regarding the specific conditions that apply to an installation. And you need to read this. Now, bear in mind again the new edition of the 18th edition regulations just confirm that the references here still apply as Appendix 5. You can check and double check. If not, you're looking for classification of external influences within your index in regards to the BS 7671 or IEE regs. Okay. Also use your on-site guide, because this also gives you quite a bit of information. Okay. Okay. And here we have compatibility. Okay. I'll just make sure that we can read this in line with this. Okay. Okay, thank you. Good. Okay. Make sure we get this into view, full screen. Okay, thank you. Okay, compatibility is the assessment by the design of any characteristics of equipment likely to have harmful effects upon other electrical equipment or other services, or likely to impair the supply. Refer to regulations 331.1 again. Confirm that you're looking at the right regulations, and you'll be looking at compatibility. Okay. Dealing briefly with each item listed, transient overvoltages can be caused by lightning strikes. Undervoltage caused by brownouts and can lead to failure of motors. Unbalanced loads can result in excessive loads of cables and switchgear. Rapidly fluctuating loads can cause unwanted operation of devices and voltage variation. Starting currents can cause localized overheating of cables and transient currents. Okay, so these are some of the things you'll need to keep your eye out for and to keep an eye on. And again, as I've said before, safety, safety, safety. And again, compatibility continues, okay? Okay. Okay, let's just get back a bit. Bring you into view. So I'm just trying to make sure that I get all the slides in, okay? Right. Harmonic currents can cause overheating in the neutral and damage to power factor correction capacitors. Earth leakage currents can cause unwanted operation of RCD. Excessive PE conductor current not due to a fault can be generated by high frequency switching. DC feedback created by switch mode power supplies and can affect protective conductors. High frequency oscillations can affect the operation of devices having frequency dependent functions. Okay, compatibility continues again. Okay, just make sure you can read this for yourselves. Okay. Now here we are, maintainability, okay? And let's make sure you can read this as well. Okay, and just come down a little bit, make sure we get that all in, okay? Maintainability, okay? So make sure we haven't missed anything, no, good. Okay, maintainability is requiring the designer to think about how often the installation will be maintained and how rigorously that maintenance will be carried out. The person maintaining the installation has an effect on the installation. Chapter 34 is making sure that The installation is not only safe at the beginning of its life, but is safe throughout its life. It requires three things from the designer. Any periodic inspection, testing, maintenance, and repair likely to be necessary can be readily and safely be carried out. Any protective measures for safety remain effective over the lifetime of the installation. The reliability of the equipment is sustained over the lifetime of the installation. Okay. Okay, let's pan out a little bit, make sure that it's can be seen by everyone. Okay. I've tried doing this from a different angle and it's not quite the same. Okay, but let's see how it comes out. Right, continuity of service. Okay, and again I'll just bring that up so it can be seen. Okay. Okay. Continuity of service. The designer must make an assessment for each circuit of any need for continuity of service considered necessary during the intended life of the installation. BS7671 uses a life support machine as an example of where such a requirement is essential. The designer must consider selection of the system, earthing such as TT, etc., selection of the protected device in order to achieve discrimination, number of circuits, multiple power supplies, use of monitoring devices. It may be the case that other types of electrical installations are not so critical as those which supply life support systems, and due account may also be taken of this in your deliberations. Okay, I hope you found this useful, and again this is for level 3, 5357 sitting girls. Okay, and some of you may be doing EAL. Okay, multi-choice questions. Again, answer the questions for me, please. Okay. And just make sure we can get to read the questions. Okay. Okay. Just pan back a bit, make sure we can get it all in. Let me just go down a little bit. Yes, we can. Okay. Go up, make sure there's nothing I've missed. Okay. Excellent. Thank you. Good. Okay, and again, here we are. Okay. Okay. Okay, just get that question in. Okay, thank you. Please do answer the questions, okay? They have to enable your recap session for yourselves, so you know what you've been looking at and can remember this and recall it in your exams. Okay, these questions do crop up. Okay, let's come back a bit and make sure that I've got it all in. Okay, click up and down. Okay, yes, we have. Thank you. Good, good. Okay, I think that's it. Okay, thank you. I hope you found this useful, and I look forward to continuing Unit 3 or 5 with you in due course. Okay, thank you.